Welcome, everyone. My name is Kamal Thareja, and I'm software lead on the Fabric project. Thank you all for joining us today for the 14th installment in our Mastering Fabric Tips and Tricks webinar series led by Manish Parashar. Next slide, please. Before we begin, I would like to share a few housekeeping items. The webinar will include a live question and answer session following the presentation. Please note that the chat feature has been disabled. If at any point you have a question, please type it into the Q&A box at the bottom of your screen and we'll answer it during the Q&A session. Last, this webinar is being recorded and will be shared with all the registrants. Next slide, please. We are joined today by our presenter, Manish Parashar. Manish is the inaugural Chief Artificial Intelligence Officer at the University of Utah. He's also the Executive Director of University's Scientific Computing and Imaging Institute, home to the 100 million 1U Responsible AI Initiative, and a presidential professor in Collard School of Computing. As the former office director of the National Science Foundation's Office of Advanced Cyber Infrastructure and co-chair of National AI Research Resource Task Force, Prasher is a leader in high-performance parallel and distributed computing, large-scale data management, and cyber infrastructure. His efforts have enabled new insights across multiple scientific domains and earned him several honors, including the Institute of Electrical and Electronics Engineers IEEE Computer Science Sydney Fernbach Award and Distinguished Service Awards from Association of Computing Machinery and Computing Research Association. He's a fellow of the American Association for the Advancement of Science and IEEE. Read more at his website, manishprasher.org. Next slide, please. I will now pass it on to Manish to start the presentation.
Thank you, Komal. Can you see my slides okay? I assume that's fine and you can hear me okay. Thank you for this opportunity to talk to you about the National Data Platform. We are really excited about this project and the capabilities it can enable. And this is a especially exciting time as we transition into the next phase of NDP. So in this talk, I'll do three things. I will talk to you a little bit about the context and why we're doing this. I will then talk about how we got started with the National Data Platform pilot project, and then I'll transition into where we are going. NDP was funded as an NSF IDSS Category 1 project starting this month, and with Ilkay Altentas from the University of California at San Diego as the PI. And so we'll talk a little bit about our plans as part of this next phase of NDP. So before I go on, I wanted to tell you a little bit about the Scientific Computing and Imaging Institute, or the SKI Institute, as we like to call it, because the way it has evolved and its basic founding principles really underline how we are planning to build out and deploy and operate national data platforms. SKI is a transdisciplinary institute that has been around for over 3 decades now. It lives at the intersection of computing, data, AI, and science more broadly, and takes a translational research and innovation approach, right? The idea is that how can we combine the foundational research with its impact on application with the appropriate feedback loops so that we can amplify and accelerate both innovation and impacts. It is based on transdisciplinary, collaborative, and convergent research, and has core strengths traditionally in visualization and imaging, but since then in scalable computing, analytics, AI, cyber infrastructure, data infrastructure specifically. And we have a whole team of software developers and engineers and and analysts that sort of tie in each project. So software development and deployment is an integral part of the what we do at the Ski Institute. And as Komal indicated, we are leading the One Utah Responsible AI initiative. The idea here is to take a translational approach and leverage AI to address important societal problems, regional problems such as air quality, environmental sustainability, and workforce, health and wellness, and through that process, advance AI itself. We are progressing with this initiative. We are in its third year, and I'd love to, in another talk, I'd love to tell you more about what we're doing as part of the Responsible AI Initiative. But transitioning to this talk and setting the stage, I think I don't need to belabor the point out here. Science, society are being transformed by data. Here are some um, interesting science results, and they're a bit dated, but I put them in there because they really highlight the need for integrating diverse data sets and using them to do really impactful insights. The first one is goes back to um, when we were trying to understand the COVID-19, the virus, and being understand how does it propagate and how and Romy Amaro from UCSD was able to combine models and data sets and most effectively provide a way of understanding how these things go around. You know, when we sneeze, what happens? And this included combining a huge number of resources, models, and data set, and really brought in not only the power of data, but the power of integrating data. The pictures I have there are taken from an article that appeared in the New York Times. And the second one is something that we couldn't have done without data, and that is imaging the event horizon of a black hole. This one is in our galaxy, the Sagittarius A star. And again, it's the idea is taking multiple data sources and being able to combine them to get the insights. And looking forward, and something I'm very passionate about, data is becoming central for us to address many important issues that are facing us, these emergencies, whether it is related to weather, extreme weather, whether it's natural disasters, cyber attacks, pandemics, right? And having a data-driven approach that combines multiple data sources has become critical to reducing the impact, providing early warning, saving lives, right? So I think I'm just giving you some examples. Of where data is becoming primary source of a lot of the insights and transformations you're seeing, and add to the mix the transcendence of AI, which has now become the essential engine driving innovation. It's causing this data renaissance in a sense where while data was previously in service to other processes for discovery and innovation, now data is becoming the central uh, source of that innovation, right? Through this data and through using AI models, we can drive innovation, drive discoveries, and really new insights possible only through data, right? Just highlighting the need to be able to address the data and have a data infrastructure that can support and accelerate this data-driven innovation. Um, so as we go there, I think one thing is obvious that data-enabled science, AI-enabled science, harnessing the promise of AI needs good data, right? And this is just a chart that appeared a little while back from, this is a Gartner AI hype cycle, and it shows how, data is exactly at the center of this and where most of the expectations are. And just to, again, highlight and underline the point, this is a statement from David Baker, who got the 2024 Nobel Prize in Chemistry, and really attributed his discoveries to having access to good, well-curated data sets, right? It's not just the meta, it's the data. And it's only when you have that data that you can do that. And this is leading to a very interesting phenomena that science and discovery is gravitating to where the data sources are, and there have been a bunch of studies that show that there is in a sense, a narrowing of the scope or the locus of scientific exploration because researchers are gravitating to the places where there's access to good data. And so, what we need to do to address that is to broaden and democratize data itself. There are a bunch of challenges that make data hard to use. There are clearly infrastructure challenges, and these are some of the things that the National Data Platform is trying to address. Right, often data ecosystems are siloed, while the real opportunities for science and also for using AI for science come in working across diverse data sources and finding connections, patterns, insights across them. The data ecosystem themselves, for many reasons, are largely siloed, and often they do not operate. They're even hard to find data outside your own domain, right? They're definitely not interoperable and composable. So that causes a huge barrier. Very inconsistent data services, again, because uh, uh, the focus is on building highly customized pipelines that makes these things very ad hoc, and there is very a little commonality that can allow them to work together. They're often very difficult to deploy and use, and and this is something I've seen very often that we seem to treat the data infrastructure separate from our computing infrastructure, and often it is non-trivial to use, for example, a federally funded computing resource along with a data resource, right? If I'm using one of the data from large facilities, I might have to first download it onto my computer or my local resource and then upload it onto the destination computing system, and that causes, if feasible, causes a lot of overheads. Um, and that is switched. This should have been user challenges, but on the user side, I think there's clearly an awareness issue. Often, as I mentioned, it's very hard for users to discover data sets and creating broad ability to then access and use those data effectively, especially in our AI-enabled workflows, can be non-trivial. Access still remains an issue, and I'll come back to this point. I go back to an example here when I was running the infrastructure for the Ocean Observatories Initiative, and we had first started streaming live video data, high definition video from the ocean floor, and was allowing users to experience phenomena in near real time. For example, underwater volcanic plumes that are coming out, eruptions. And some of the institutions would just grab that data the moment it started streaming, and others would send me a disk via FedEx and say, "Can you please load the data?" Right. So access diversity remains a huge, huge issue. Um, Often, the problem with data increasingly is there's too much of it, right? So if I go and ask for a data source somewhere, I get a whole bunch of data source, and I'm not sure what the provenance of that data set is, whether I can trust it, and how do I find the data set that's fit for use to me, right? And then how do I become a part of a data community, right? It's okay if I'm part of the community already, but becoming part of a bigger data community becomes a challenge. So these are just a few I've listed. There are clearly a bunch of challenges that make data and data access and data use hard, right? And our goal is to move beyond just having data open, right? We often say this data is open, but how do you make sure that it's not only open, but it's useful, it is usable, and then it actually gets used in science, in innovation, in discoveries. I wanted to take a minute to just try to highlight some of the motivations here and background because the NDP was funded within the context of the National AI Research Resource as a pilot project a couple of years back. And the goal of the NAIR was to see how we can democratize AI. It came out in 2023, and the recognition was that AI is going to be transformative, and we wanted to make sure that everybody had access to the resources and was able to contribute to the research, to the AI research and development ecosystem. So the NAIR task force, I had the privilege of co-chairing the task force, came up with a report trying to propose a national infrastructure that can support AI R&D for everybody, right? How can you use it to spur innovation, to increase diversity, improve US capacity, and just advance trustworthy AI? And if you look at the report, it recognized early that central to this is actually having data, accessible data that users can leverage to build, train their models to uh, enable AI enabled discovery, right? So having these curated data sets and data commons, data infrastructure is really central to having or enabling this democratization of AI R&D. And that remains only more important. It's just growing in importance over the years as AI becomes more central to everything that we do. So let me now talk about the beginning. So as I said, the task force recommended this about 2.5 years back. NSF funded the National Data Platform um, pilot, and now we are moving into what's called the Category 2. So let me give you a broader vision and overview, and then talk a little bit about the pilot and how we got there. Right. So the whole idea or the challenge that NDP is trying to address, and I touched on this a little bit already, is that data is siloed, right? And there is a lot of data. NSF, through the years, and other federal agencies have funded tremendous data sources. There's a lot of data sources coming in from the states and the academic institutions and other places. So there is a lot of very good, very important data that can really drive new insights. But this remains siloed and very hard to use. And as I also mentioned, compute is fragmented, right? There are all these different compute capabilities, uh, often far away from the data, and they are very hard to use together. And then add to the AI, which depends on this compute and data. Well, it is also hard to integrate and work with all these different sources together. And so building a, a workflow that combines all these pieces remains really non-trivial, right? So how do you build these AI-enabled agentic workflows that can seamlessly integrate these pieces? Clearly, our infrastructure to enable that has to evolve to be able to support this mode of discovery moving forward. And of course, the other part of it is that we need to train the workforce that's able to leverage this and use this as an integral part about how they create, how they innovate, how they discover. Right. And so we need to train, and to train them, you need to have an infrastructure where they can be trained in an effective manner. Right. So these are the challenges, the observations that we have seen in terms of national needs that are driving the national data platform. Um, and and so what we're trying to do is to bridge these gaps, right? Can we leverage the nation's distributed data repositories, facilities, computing capabilities, all the pieces that exist into a whole where this whole is much greater than sum of the part and does help us achieve this dream of AI-driven innovation that really is getting closer and closer. Okay. So in terms of its vision and goals, NDP is trying to unify, connect these different pieces together. And through this connective fabric that we create, this platform, we want to accelerate innovation, accelerate discoveries by connecting the data, the compute, the expertise together as part of these innovation workflows. We want to reduce the barriers so we actually allow everybody to innovate with these resources, to truly democratize in keeping with the vision and goals of the NAIR, truly democratize access, use, and innovation using data. And then, of course, innovate not just in what we do with these resources and with the data, but in the infrastructure itself, because we have to keep on evolving as the capabilities and technologies evolve. We want to make sure the infrastructure evolves to keep up with the science it can enable. Um, there are a lot of capabilities we are trying to build around this. I will just pick on a few. For example, workforce development is a big part of it. Collaborative workspace, we understand that science is essentially necessarily a team sport, and so you need to be able to collaborate, but you need to collaborate around these common data abstractions and workflows. And how do you support that? Leveraging agentic assistants that can be accelerators of the human creativity and innovation, right? How do you support that natively? Bring in the digital assets, not just data sets, but software and models and other artifacts together. Ensure that we support the FAIR principles in data and knowledge. Make sure that discovery is integral to catalogs and other mechanisms, uh, build on an evolving national cyber infrastructure and federate it together, make sure that we are having interfaces and dashboards supported, reduce the barriers by having things such as reusable innovation factories. Right, so there are a lot of goals, right, and then building this all on a governance and interoperability fabric, right? So the idea here is to not start from scratch, build on capabilities that infrastructure researchers, cyber infrastructure providers such as Fabric are already providing, bring them together, connect them, and then create a whole that can enable these capabilities for end science. Who is NDP for? And this is just trying to make sure that we have our user community, our stakeholders in mind as we build it, as we deploy it, as we operate it. It includes researchers and scientists. These are end researchers who are asking the question that can be answered using data and data enabled capabilities, AI models, things like that, right? Data softwares and engineers. These are developers, researchers, innovators that are extending the data ecosystem, are using data as part of the innovation that they're doing. AI developers, again, data is critical and impacts the quality of the AI models and capabilities that they build. Educators and students are critical. As I mentioned right from the beginning, we want to make sure that developing our AI ready workforce is central to our mission. Institutions and communities that are connecting their data sets so that their data sets are part of this innovation ecosystem that we are building, that they are represented in that, and they can be part of this broader community. And last but not the least are the policymakers and program managers so they can track data and the impacts of the data they're having. So how do you have the right metrics and the right dashboards and right uh, information that they can understand where to invest, where the impacts are, and how the impacts are of their investments are manifesting themselves. Okay, so let me spend a little time talking about what we've done in the last about 2.5 years now, getting to this point to this category one funding in terms of the NDP pilot, right? We started from almost zero and we have been building a bunch of services and along the way learning about what works, but most importantly, building the right partnerships and collaborations with end users, with other infrastructure providers, so we can deliver on the broader vision of the National Data Platform. So the National Data Platform pilot started again under the leadership of Ilkay at UCSD. And the idea was to build a broad federated data ecosystem to promote collaboration and innovation. And our model was always to build on capabilities that already existed. The goal was not to reinvent the wheel, but to see how we can connect the pieces together. What are the value added services that we could bring that could make existing capabilities more usable and more effective in terms from a end user and a science perspective, right? And in the pilot, what we've done is being able to build services that can facilitate the discovery and use of data along the FAIR principles, right? So we have a catalog where data sources can be, or digital assets can be registered, and they can be discovered in a consistent way, right? So NDP is Pilot was not created as a data store, so we don't store the data. We curate the metadata so that it can be discovered and used, right? So data stays with the data provider. And we have a whole range of discovery services. I'll talk a little bit about it as I go along, but trying to see how we might make it easier to find the data, right? Recognizing that more than 90% of the data is not really scientific data, is not really curated, right? So how do you make things discoverable given that? How do we provide these collaborative and customizable services, collaborative workspace and customizable services so that you can improve the utilization of data, right? So I don't have to download all the data and figure out how to compose it. Can I provide the services so that the data sets can be more effectively used through these near data services? How do we connect on with the national cyber infrastructure and cloud resources? There's a rich set of resources out there. How can we bring them in using a bring your own resource, bring your own uh, resource model where users can say, I want to run this workflow, but here are the resources I want to use to run this workflow. We've recognize that AI is going to be integral to what we go for. So how do we make this whole platform AI integrated, AI native, so that we can bring in these models and these agentic approaches into what we do here? And then again, I have mentioned this a few times now. Data challenges, learning experiences, classrooms is a first-class citizen in everything we do, and it is built into the portal. We have a separate education hub that really allows us to make sure that we are building the workforce as we are innovating in the infrastructure. Architecturally, it's made up of two pieces. On one side, we have the NDP hub, and this is the central entry point. It's a centralized portal for discovery access, for creating these workspaces, for discovering data sets, for integrating a workflow, for creating data challenges, have educational material. It all comes into the data hub, right? It's centrally deployed with the due robustness, redundancies, failovers that are needed, but it is the central entry point for NDP. And we have a bunch of services that run in there that allows us to really enter into this data ecosystem. Collaborative workspace is a big part of it. Discovery tools is a big part of it. Interactive classrooms. But on the other side, we have a federated network of AI of data endpoints or connecting or right of these data endpoint platforms. And what these do are these are really lightweight Kubernetes-based software stacks that run. They can be stood up as needed in front of data sources in terms of communities. Right? They allow you to run services that allows us to access the platform dataset, but also host services that make that data more usable, right? So can be, right? They have basic services for discovery, for authentication, for federation, but on top of that, you can build custom stacks that are customized to the data source or to the data um, asset that's out there, and that makes it more usable. For example, if there is a data set that uh, that users use a set of services, for example, for subsetting or for analytics or for filtering, right? Those data services can be deployed close to a data source, so not the users can use them effectively and be able to improve their usability of the data. And these can be customized by the data. So you can think about on the other side, right? If a community is using fusion of multiple data sources, they can run these services in front of the community so that we can do this integration just once, right? So it's a very scalable way of creating custom data experiences using these near data services. And all of these are connected to bring your own resources so that you can deploy these services and provide them to the community. Digging a little deeper, one level deeper, right? So on the hub side, right, you have these classrooms, data challenges, all made up of workspaces. A workspace can have different digital assets such as models, data, services, endpoints. You use these, and these services and data come in through these endpoints, right? So you can compose workflows leveraging services that are hosted at these endpoints. We also have a catalog at the hub that allows us to then discover these data sets, but other data assets such as services and models as well. And on the other side, we have this bunch of different endpoints. Each of them has certain standard services for federation. Um, but then you can create custom services, right? For example, for one of our use cases that I talked about, right, we've been hosting a streaming service and a data uh, staging service and a remote execution service, right? These are third-party services that run on the endpoint that then can make this data source, in this case, the Earthscope data streaming resource, more usable from the end user community. And I'll explain that in as I describe use cases moving forward. Um, just to go into a little more detail about some of these custom services so they get a feeling as what we can do with these custom services. The science data exchange service that we have built as an example of customization has a data staging service, right? And what that does is allows us to read data from the data source, hold it in memory in an index way where you can then run queries or operations on that data rather than download it, right? So you can say, hey, read in this new satellite image that came in, see if it has got, triage it. Is it useful? If not, I'm not interested, but if it's useful, download it into my workflow wherever that is executing, right? It allows us to manage a lot of these large data in resources in an in situ manner. Similarly, we can manage data in motion, streaming services. When you have large number of streaming services, how do I efficiently filter these services? Right, and this is just an example that we were working with NASA on, right? They were leveraging Go's data services as part of their workflow, and NOAA Go's publishes data in S3 uh, from their satellite images on a regular basis, right? So NASA was interested in downloading only relevant images when they found certain patterns. So rather than downloading all the data every time an image came, they staged the data in memory on a few nodes in S3 and used this as a way to only detect interesting images that they would then feed into their on-prem workflow that was running at NASA Ames. Again, the idea here was to stage the data. So we set up an endpoint. They ran a staging service there, and they were able to reduce the amount of data they actually had to download from the cloud, but also how often they had to run their workflow on their on-prem system, right? So it's just an interesting way to be able to run services at source in an interoperable and scalable manner. And then we have the streaming service, which allows us to detect different types of streaming data, being able to filter them and to be able to detect or to create derived streams that only contain the data that's relevant to the community. And this becomes interesting because as we see these observatories coming in, they have thousands and thousands of streams of different kinds of data, and that can quickly become overwhelming, right? So being able to create streams of only relevant data in a flexible manner makes those data sources so much more effective. And so we have got a very standard way of being able to do that that gets deployed on the endpoint, and then users can program it to be able to get the streams that is most interesting to them. Again, um, simple services, but just improve the usability of the data in a scalable manner, right? And that's what we're trying to do, not to recreate what these data sources are already doing, but to create a platform where we can increase the value both individually and collectively of these data sources. Just to give you an example, this is one that we've been working on sometime. This is an early earthquake warning workflow that we've been working for some time. And the idea here was, can I combine seismic data with GPS data, which can detect uh, displacements, right? And by combining these data sources, right, you can detect these early waves, which allows us to get a little additional time or additional warning of an impending earthquake, and that allows you to do things such as shut down public transportation or evacuate critical things like hospitals, right? So it just gives us a little more gives us an earlier warning, right? By if we can combine these data sources. Clearly, there's a lot of research going on how to do this. We had come up with one algorithm for doing that, but that required taking normal seismic data, but bringing in GPS data with that. And that turned out in practice to be a lot more challenging than we thought it would be. And so we worked with the EarthScope NSF Observatory to be able to do that. Now, EarthScope does stream live GPS data from the GNSS satellite system, and this has got thousands of multiple thousands of 1 hertz stream coming in. Right. And so the immediate point was, okay, how do I find the data in this large amount of data that is relevant to what I'm trying to do, right? So we set up this endpoint in front of the facility, right? And this is working with EarthScope. And what it does is allows us to then use our filtering service to be able to filter that data and say, I'm really interested in this region and streams that have a displacement greater than so much, then create a derived stream and only send me that data, right? And since I'm looking for exceptions when there is a possible earthquake, right, it just reduces the amount of data I have to process significantly, right? And users can customize it to what they need, and so it provides these value-added services from a existing facility. This is an NSF major facility to be able to make their data streams more usable from a user perspective. Clearly, we do a few other things as well here using services in the Open Science Grid to be able to do near real-time and analysis to find out trends and things like that. Here's another use case just to give you an idea. This is something that is very important to us in Salt Lake City in Utah, where we have an air quality problem due to inversion, due to the geography, where we can find huge both spatial and temporal changes in air quality, and to be able to get near-term forecasts that are actionable is hard. For example, if I want to know whether I can, you know, go to you go out running in the afternoon, or when do I have recess for the students, or when should a elderly person go shopping, right? These kind of forecasts can be very hard to give. And so what we did was to create an endpoint which queries large models such as Aurora out of Microsoft. This is a large ML AI model that provides coarse grain forecasts, right? You can find coarse grain forecasts, use that to filter into streams that are most relevant, find hotspots from the coarse grain, filter in, get data only from those sensors that are relevant, and then create fine grain forecasts based on that. Right. So this is a project again being able to fuse different capabilities at the endpoint and be able to then make that as a value-added service that then the community can use. Again, there are QR codes on these that take you to demos that you can then play uh, with these workflows. And there are a few others here. I won't go into them. I'll talk a little bit about the search, and um, I will go through this quickly. We have different ways to look for data. I think this is one of the hardest problems, finding data. We clearly have catalogs using meta-text searches. We have conceptual searches using knowledge networks. We have spatial searches where I can say, show me sensors or data sources in this region, right? So there's clearly ways that we can use metadata to navigate the data. But we have been trying to think a lot about how do we deal with dark data. And this is data that has not been curated. And that can be hard to do because, well, the data isn't curated. There's a lot of ambiguity. So how do you go and find data out there that you don't have nice, clean metadata that I can search? Um, and we've been trying to come up with a way that I can then get that, not only find that data, but also try to make sure that it is fit for use to answer, it's the right data to answer the science questions that I want to ask. I won't be able to go into details here. I just wanted to show you the concept and then move on. I'm looking at the time as well, so I want to make sure I wrap up in time. So the basic idea is the notion of use descriptors. Usage descriptors are structures that try to explore how that data set is used. And the way we do this is to um, mine using AI large numbers of publication, figure out use patterns, and being able to automatically make a determination of whether the data is actually being used and how it is being used. And once we make that determination, we try to quantify what is the impact of that use, all using AI agentic workflows in an automated fashion. We partner with Dimensions, which has 20 million publications, and we use this way to be able to automatically try to create a community around the data as to who's using the data, how they're using the data, what is the impact of their use, what data sets are being used together, what software and models are being used with that data. Once you have this rich knowledge graph, we can then present it to the user, which allows them to look at those connections and get a better trust understanding of the data, and it's fit for use, right? And so that's what this slide is saying. We use a community-based approach to find data that's fit for use by figuring out who's using the data and for what research, what's the impact of the data that they're using, what data sets are being used together, and what tools and codes are being used with that data. Again, it's a portal. You can go in there, and I think the next slide talks a little bit about this, right? So the way we do this is, as I mentioned, when a data set comes in, we index it using terms. We then run it across this corpora of data sets, whether it's Dimensions, OpenAlex, PubMed, and then figure out what is this knowledge graph of who's using the data, and then we present it in the portal, which looks something like this on the right of this slide, right? You can see uh, uh, some keywords on a word cloud of how the data is used, but then you can navigate into actual publications using the data. You can figure out citation counts for that data, right? The whole idea is that users should be able to say, I want to solve this problem, or I'm trying to address this research question. What data set should I use and why? And how do you create an environment to do that? You can go to insights.ndp.utah.edu, or you can even go to nationaldataplatform.org, and you can navigate a bunch of data sets where you can find this kind of rich metadata about discovering data. Okay, I'm going to spend a few minutes now just talking about where we're going from here. And this is NDP 2.0. This is the IDSS Category 1 project that was just funded. And we are uh, putting the team together and getting started to move on this, right? So the first thing we're trying to do is to take all the pieces that we have experimented with, the lessons learned, come up with a microservices based layered architecture that's built around the seven key principles of usability, interoperability, extensibility, reusability, composability, scalability, and trustworthiness, right? So these are our four guiding principles. We have a lot of experience in components. How do we build on these to come up with this architecture? And as you can see, right, we have the hardware capabilities, that is the compute fabric. It's a lot of it is bring your own resources, but we have invested in certain resources as part of this grant to create anchor points. Uh, but we understand that users will have custom requirements and want to bring them to this platform. Uh, a lot of the endpoint architecture I talked about becomes a platform as a service. And then on top of that, right, we build these canonical workflows as innovation templates that users can use to be able to use services, compose them into these end-to-end solutions, right? And then we are looking at a portal not only as an entry point to NDP, but also as a service, right? So, for example, I want to create a custom portal on top of the service stack for my domain, right? How can we create portal as a service itself, right? And the whole idea is to make sure that we are focused on the user on usability, but also in terms of scalability and composability as the guiding principles there, right? And of course, governance is integral to all of this. We should be able to define policy structures, governance mechanisms across the entire stack. And this is also offered as service. So, for example, if I'm building a application or I'm building a portal and I want to define my own policy framework around it, I should be able to bring that in and deploy it within the stack, right? So the idea here is to provide a set of services and infrastructure platform that can be used by a user community to really make data and infrastructure most usable to address their science questions and the science challenges. I've already talked through this, right? A lot of this is built on technologies that and solutions that we have already piloted and proven to be effective as part of our pilot project over the last 2.5 years. So we are building on a lot of these things and the lessons learned so we can move this forward in an effective and integrated manner. We are driven by 8 co-design application drivers that are representative of the type of applications we want to do. And here they're listed out here, including the scientists that is leading them, right? Our collaborators. These include AI-driven agriculture, precision agriculture, air quality, and some of the examples I talked about, biomedical digital twins, earthquake warning, linguistic, hydrology, material science, particle physics, right? So important uh, science drivers that bring unique capabilities that use data and AI in innovative ways to able to solution. And while we address these specifically in the project, the idea is to use them to define innovation templates that can be generalized to other applications in the domain, other applications that match that pattern and are accessible by the broader community to lower the barriers to using the infrastructure and doing data-driven AI-enabled innovation in science. Like any project, we have sort of this coupled co-design process where have a design track where we're doing constant exploration of technologies, given how fast it's changing, of solutions, of needs, and being able to co-design, innovate while we have the production track and a translational pathway that takes this co-design and innovation and moves that into these production so that users can use it. And of course, we have a feedback so that as new user experiences, user needs come in, we are able to continue to innovate and build and evolve the platform. As I mentioned, we have 5 cross-cutting uh, patterns: agentic AI, event-driven decision support, whether it's wildfires whether it is for um, earthquakes. And this is really focusing on the time critical decision making and how can you get the right data and the right confidence in the data to be able to make this important decision support. How do we integrate edge and HPC that, and this could be edge in terms of sensors, but in terms of large instruments, simulation in the loop digital twins, especially in the medical space, but even beyond that, uh, autonomous laboratories. This is again in material design and other places, and uh, just knowledge exploration, right? How do you do data fusion and knowledge graphs more generally for a lot of different applications? Um, as I said, we don't want to reinvent the wheel, and the underlying concept, principle, goal here is to build on what exists and use this as a way to amplify the impact and the use of this investment, these resources that already exist, whether it is NSF computing infrastructure, whether it's foundational platforms, data repositories, educational networks. There's a lot of investment, right? And we are trying to be the integrator, the glue, the value added services that can bring this to the user community and be able to be effective individually, of course, but collectively, right? So how can I combine these pieces together to help users more effectively address their science questions? And I think this is where our partnership are hopeful that we can work with Fabric to bring its unique capabilities, its unique infrastructure and resources and expertise as part of these workflows, right? And I just was thinking aloud as to what those interfaces might be, right? And these are just some thoughts. I'm hoping this may seed other ideas on your perspective, right? And we are open to collaborations because we feel this partnership can be very effective. Again, Fabric does a lot of very interesting things in terms of bringing high performance, high throughput, programmable network infrastructure to the end user, both for innovation in network, but also in science innovation, right? So how can we combine these together, for example, to do interesting data staging and transport so that we can make better use of large data sources and streaming data along with our networking capabilities? How do we, you know, leverage the non-trivial capability for processing and innovative analytics can be done in the network? How do we more effectively connect to our edge? How do we make sure we have end-to-end security and of the data and we maintain the integrity of the data as it moves through these workflows, right? And these are some ideas, some food for thought as to where we might work together. But I think there's a lot of potential of coming together and building on our unique capabilities where we can together provide some uh, really services that can enable science moving forward. So to summarize, right, what are we trying to do in NDP? We complete ecosystem, generalized workflow patterns, production grade. We had 2.5 years to build a pilot and proof technologies. So we want to start with production on day one and then improve it as we go along. Workforce is really important, and we have spent a lot of time for making sure we have the infrastructure and capabilities and services needed to be able to train the workflow to use these capabilities. And as I mentioned, open, fair, governable is so important for data, and that's integral to the solution that we are building. So thank you. On here, you can see all the partners here. Ilkay, as I mentioned, is the PI. We have partners at the Texas Civic Computing Center at the University of Texas, Austin, at the University of uh, um, Washington, and at the University of Massachusetts and the MHCC. So thank you again for your attention. I really appreciate it. And this is a one slide summary of everything I talked about. I will stop here and turn it back to my host, Komal.
Thank you again to our presenters, Manish Parashar. In addition to our presenter, we would like to acknowledge the uh, behind the scenes team listed here who worked diligently to bring this webinar to production. Next slides, please. I
I
think, um, I think Chelsea, could you please share the slides? Oh, okay. I am so sorry. Went way too ahead. We are at the Q&A session, and I messed up. Apologize for that. Let's begin with the questions submitted during the presentation, and we'll now we've already stopped the screen share, and I will pass on the questions. Uh,
I
is
can go ahead. Sorry.
Yeah. The first question is NDP being set up as a vertical agnostic data platform that can be safely considered as source of truth, and will it be open source?
So I think there are a few different questions there. So yes, we're trying to make sure it's vertically agnostic, right? In the sense that it provides capability so you can create verticals on top of it, right? And the idea is that as we have new needs assessments, we create additional services that allows new verticals to evolve. Um, I don't think it provides you the pieces that you need to make a determination whether this is the right data or the source for you, right? It doesn't guarantee that. It doesn't do certification, for instance, but it has the provenance, the metadata. It provides the like the discovery service that I talked about, the rich contextual information, right? That allows you to make a determination of whether this is the right data, how much trust you have in that data, right? So, but it doesn't have a certification that says this is the source of truth, for instance. But I can see that this can provide a resource to make that kind of determination.
Okay.
um, what is sorry, I'm reading ahead. Yes, it will be open source. Sorry.
Okay. Thank you. What is Fabric with reference to NDP?
I think it is a provider of capabilities that NDP services can leverage, both from a research perspective. Let's say I'm trying to build a better data service, and I'm trying to architect a better way to execute my workflow, my end-to-end workflow. I can leverage Fabric to do some of the innovation there, right? So I can use that. I can compose a workflow, execute in Fabric to be able to use innovative data staging or network transport protocols, right? I'm making this up at this point. So in that sense, it is a service resource provider that can be used along with NDP services from a user's perspective.
Okay. How do you compare NDP to commercial platforms such as Hugging Face or AWS Data Exchange in terms of concept, scope, functionality? I mean, ignore the pricing, obviously.
Yeah. So I think this is integrative. For example, all right, we do allow you to bring Hugging Face models into an NDP workspace and integrate it into our workflows. I use Hugging Face to discover how which models are being able to use to be are being used with the data so users can discover them, right? So we have integrated that. Same thing with AWS, right? A lot of the endpoints run on AWS. We can run services on AWS, right? So in a sense, in that sense, we are trying to leverage these capabilities and allow you to bring them in, and not try to replicate what they're already doing. There is some replication um, because of the pricing and other reasons, but if users want to use an AWS service, right, they can use it within NDP.
Okay. Air quality, is there a data set for air quality of US cities from EPA? And if not, which of the data sets is close to cover air quality over US?
There are a bunch of data sources that are there. There is a NASA satellite data that comes in. We run in in Utah. There are a bunch of projects that I collaborated with, which have sensors deployed across. These are PM sensors, particulate matter sensors across Utah. Um, I can, if you want to send me an email, I can get you those names. I don't remember all of them off the top of my head, but there are a bunch of sources of air quality data.
How would you compare features of NDP with Globus?
I think NDP uses Globus in the sense, right? So we need to move data. We can leverage global services to do the data transport, right? There are other capabilities like Globus, the Funcax and things like that that Globus provides. We have yet to integrate those, but the core data movement service that Globus provides, we have used that within NDP.
Okay. Another user is asking if they would be curious about the sustainability of NDP beyond the 5 years of funding. That is, if we host a project or an open resource on NDP, what will happen afterwards?
So we've been thinking a lot about that, right? Because this is something about infrastructure you always have to think about even before you write the proposal. Um, so we've thought about there are a few pieces to NDP. One is the core hub, right, which is largely a catalog, right? So there's some effort to sustain that, right? Mainly the catalog and the base core services. But a lot of the endpoints, right, in an ideal case, become owned by the community that runs them, right? They bring it in because it adds value to them and create a community. They bring the resources. That's why we go with the bring your own resource. The idea is to address sustainability. There's clearly initial seeding that NSF is going to be doing in terms of endpoints, in terms of infrastructure. But I think the idea is that there's enough value add in being part of the federation that you stand up an endpoint in front of your community or your data resource, and then you own it and you manage it and it becomes part of the federation, right? So that's the model we hope to get to by the end of the project.
What do you see as the biggest shift in how researchers will interact with scientific data over the next 5 to 10 years?
That's a very interesting question, right? I mean, uh, what is the Yogi Berraism about predicting the future? Anyway, so I think a few things, right? I think a lot of the data is going to be used in the context of AI and AI-enabled workflows, right? So that changes, um, right? So while we are focused when humans, and I'm speculating here, right? So when humans use data, a lot of the focus is on the how clean the data is, right? And how agents, I think more important there is the provenance of the data, right? They can deal with not AI can deal with noisy data, right? But you need to make sure you understand where the data is, and an agent can make a determination whether that's the right data to use, right? So so that I think will be a shift we are going to see. The other thing we're going to see is that we'll increasingly use data. Right now, we limit it to data that I know where I get it from, I bring it, and then I use it. Right, with the agentic workflow, there'll be more for dynamic discovery, and you'll be using data from sources you may not know, right? And their data says they don't have. So you have to again be able to make a determination with the right data, right? Even though it may be coming from a source that you don't individually, personally recognize, right? So how do you have that ecosystem? I think these are opportunities of what AI brings, but also makes us rethink how the data is going to be used. But data clearly is going to only grow and increase. And I think being able to address and keep in mind that a lot of the workflows and uses are going to be AI enabled, AI augmented, if not AI itself, right? So we have to be cognizant and see what that means for our infrastructure. Those are some of the things that come to my mind immediately. I'm sure there are others.
Thank you. The National Data Platform aims to make data more discoverable, trustworthy, and reusable. What do you think will be the biggest challenge to widespread adoption across the research community?
I think it's make sure is to build the ability while we build the capability, right? We're building this capability, but we also make sure that the users are part of it. So that's a big part of it, right? You cannot go into the build it and they will come kind of mode, right? And so that's what we have done, right? And the second thing is being intentionally usage user driven, right? There, right? And so we think a lot and see why we are building a certain service. Who is the target user? Can they use it? Is it being used? Right. So answer all these questions before we move on. Right. And so those are the things that I think are important as we move forward.
You discussed the importance of connecting data with compute resources. How do you envision platforms like NDP working alongside research cyber infrastructure such as Fabric to accelerate scientific discovery?
Um, I think this is something we both have to discover together, right? I think there's a lot of capability because our needs in terms of infrastructure is changing, is growing, and I think Fabric gives us the ability to do that innovation, right? And it changes the question, right? A lot of times we have said, this is the infrastructure, do the best you can with it, right? This asks the having an infrastructure like Fabric changes the question. It says that this is what I want to do. How do I design the infrastructure that allows me to do that, right? And so without an infrastructure like Fabric, you cannot ask that question. So I think it's very promising. Again, the details is something that I'm hoping I have a chance to have a conversation with the Fabric community and learn how we make that possible.
We have a last question. Many disciplines still lack well-curated, accessible datasets. What opportunities do you see for researchers in emerging or unprecedented, underrepresented fields to contribute to and benefit from with NDP?
I think this is really a extremely important question again, especially with AI, right? I think part of it is that we are limiting a lot of what we do because we are limited in the data we have. It's like, you have this story about this person looking for something under a lamp, and they said, "Did you lose it?" No, but that's where the light is, right? And that's with data, right? A lot of the investigation happens where the data is, where the curated and good data, right? So if you want to truly broaden scientific exploration using AI, we have to broaden the data, right? And that means diversity in the sources of data, in the types of data, where it's coming from, what does it represent, and that means lowering the barrier, increasing the capability of the researchers to be able to contribute the data. And that's the whole purpose why we started with the education hub, right? Rather than building it science and then adding it on, right? This is the first thing. And right now, the largest number of current NDP users are educators that are running classes in them, right? Because that was our first target. We said, unless you can build sophisticated capabilities, but if our goal is to democratize this, we have to build the ability in parallel with the capability. And so, how do you make sure that you have that, right? So, I think that's a hard question, but those are some of the things that we're trying to do.
Thank you again to our presenters, Manish Parashar. In addition to our presenter, we would like to acknowledge the behind the scenes team listed here who worked diligently to bring this webinar to production. Uh, Next slide. Oh, okay. And thank you to the audience for your participation in today's webinar. In addition to recording of this webinar, we'll also email everyone who has registered a list of resources. This slide deck would be shared along with our Connect with Us form. We hope that you'll reach out to Fabric team for questions or support. Next slide, please. Our webinar next month is August 18th at 3 p.m. Eastern, Stitching Together Innovation with Fabric Users. The webinar will be focused towards new users. We would appreciate if you could share it with others. As a final reminder, please submit your Fabric matrix and make sure your project description in the portal is up to date. And we'll use that information for outreach, including our website. Thank you again and have a wonderful day, everyone. See you next time.
Thank you. Bye.
Thank you. Bye.